This video is on the end behavior of polynomial functions. So now we're going to start by looking at some graphs. Now what I mean by end behavior is each function has a right end and a left end. And for polynomial functions, as you go in one direction, it might do some up and down in the middle, but eventually you get to a point where it'll go down and down and down forever, or up and up and up forever. So we're looking for, as you go to the right forever, is this going to go down and down or up and up? The way we're going to specify this mathematically, the right end is always the x-coordinates are going towards infinity. So we'll say as x approaches infinity, here the y-coordinates, this goes down and down, so y goes to negative infinity. Now if we want to talk about the left end, the x-coordinates are going in this direction. They're getting to be larger and larger negative numbers. So as x goes to negative infinity, on the left end here, the y-coordinates are going up and up, so y goes to positive infinity. Our second example here, on the right end, as x goes to infinity, so that's my right end, y goes to negative infinity. I'm going down and down. Notice here my left end is also going down and down. So as x goes to negative infinity, y goes to negative infinity. Notice here my ends went in opposite directions. Here they went in the same direction. You can have either one of those. It does tell you something about the degree of the function, which we'll get to in a minute. So here as x goes to infinity, that's my right end. This function is going up, so y goes to positive infinity. As x goes to negative infinity, that means I need to look at the left end. The left end is also going up, so y goes to positive infinity. And finally, on this last wiggly little one, as x goes to positive infinity, that means I'm looking at my right end. This is going up, so y goes to positive infinity. And as x goes to negative infinity, so I look at my left end, y goes to negative infinity. This is going down. So that's reading end behavior from graphs. We can also do this based on an equation. Let's start with a single example. I want to consider the function f of x equals negative 3x squared plus 5x minus 12. So this is a quadratic function, but a quadratic function is just a simple kind of polynomial. To find the end behavior of the right end, we need to consider what happens when we substitute very large positive numbers into this function. So, say I take 1,000,000 and find f of 1,000,000. I'd have negative 3 times 1,000,000 squared plus 5,000,000 minus 12. Now when I'm dealing with numbers on this scale, this minus 12 is really not going to impact much of anything. And in fact, when I'm comparing 1,000,000 squared, that would be 10 to the 12th. That's just a huge, mind-bogglingly huge number. 5,000,000 really won't even compare. So the only thing I need to look at if I'm thinking about end behavior is this first term. Now I'm taking that very huge positive number and squaring it. That won't change the sign. remember, if you raise something to an even exponent, you'll get something that's positive no matter whether you start with something that's positive or negative. If you raise it to an odd exponent, you keep the same sign, but in this case, when we're thinking about the right end, we're only thinking about substituting in positive numbers. So x squared is going to be positive no matter what. Then I'm going to multiply that by a -3. The fact that it's a 3 doesn't matter very much, but the fact that it's a negative does. So since I'm going to be multiplying this by a negative, this entire thing is going to give me a negative value. The larger of an x value I put in, I'm going to get a larger and larger negative value. So, as x goes to infinity, y is going to go to -infinity. Now, to find the end behavior of the left end, we want to consider what happens when we substitute very large negative numbers. Again, that -12 isn't going to matter once we're talking about very large numbers. This 5x won't even matter. I really only have to think about this first term, the term with the highest degree. You'll hear this sometimes referred to as the dominating term. Well, if I substitute something large and negative in, I'm squaring it, so I'll end up with something very large and positive. Then I multiply by -3, and I'm going to end up with something that's negative. So as x approaches -infinity, y is going to approach -infinity. So that was for one fairly simple example. Let's have some generalizations from this. If the lead coefficient is positive, then the right end heads up. Remember, we only have to think about the first term, and the lead coefficient is the coefficient of that dominating term. And now heading up is not mathematically precise language, but we can put that into our new notation. As x approaches infinity, so that's my right end, y will approach infinity. So now, if the lead coefficient is negative, like we had in the previous example, the right end heads down for exactly the same reasons we had in the example. And this lets us conclude, as x approaches infinity, y approaches -infinity. So now it's very easy to tell what the behavior of the right end of the function is just by looking at the lead coefficient. Then we're going to want some facts about the degree of a polynomial. If the degree of the polynomial function is even, the ends head in the same direction. Both the right end and the left end will head in the same direction, which is either y going towards infinity or y going towards -infinity. If your degree of your polynomial function is even, it's going to be the same for both ends. If the degree of the polynomial function is odd, then it's going to be opposite. If one of them is y going to positive infinity, then the other must be y going to -infinity. If the right end goes to -infinity, then the left end will go to positive infinity. So let's look at several examples now. We want to find the end behavior of each function. Here's our first function. Now remember, I don't need to know the rest of the function when all I'm interested in is the end behavior. I can just look at this dominating term. Now, let's see, let's have some blanks here. I want to know the end behavior for both my right end and my left end. Now my right end is always the x values are going towards positive infinity. My left end, always the x values will go towards negative infinity. It's really a question of what the y's are doing. So I look at my lead coefficient. It is negative, which means the right end, the y values, will go to negative infinity. The next thing I want to consider is the degree of the polynomial. This is a 5th degree polynomial, and 5 is an odd number, which means the ends have opposite behavior. So since the right end goes to negative infinity, the y's on the left end will go to positive infinity. And there's my end behavior. Let's do another one. So I've got g of x equals 5x to the 101 minus 437x to the 52. So even though this is a very large coefficient, and x to the 52 certainly is a sizable degree for this term, the degree of my polynomial is 101, so I just want to look at my dominating term. I ignore this one altogether. I've got my fill in the blanks here. So on the right end, remember the x's on the right always go to infinity. The x's on the left always go to negative infinity. Now the y's on the right, this is when it starts to be interesting. The y's on the right, I have to look at this particular function. I look at the lead coefficient and it's positive, which means the y's on the right end go to positive infinity. Now I look at the degree. This function has an odd degree, which means the ends have opposite behavior. I have a positive infinity on the right, which means I have a negative infinity on the left. And there's my end behavior for that function. Let's do one more. So I've got h of x equals 8x to the 4th plus 54x cubed plus 101x. Now, again, the x's on the right end always go to positive infinity. The x's on the left end always go to negative infinity. The y's on the right end, I look at the lead coefficient. This is positive, and so the y's on the right go to positive infinity. The y's on the left end, I need to look at the degree. The degree of this is 4, which is an even number, which means my two ends go in the same direction. So since I have y going to positive infinity on the right, I also need y going to positive infinity on the left. And there's the end behavior of that function. Next, watch the video on root behavior and other polynomial graphing stuff.